Welcome to the Reasons to Believe Scholar Community Workshop. I am George Haraxon. I get to serve as the Scholar Community Program Director. I want to introduce our first speaker, Dr. David Block. Dr. Block is a professor emeritus in the School of Computer Science and Applied Mathematics at the University of Witwatersrand, Johannesburg, South Africa. Dr. Block was elected a Fellow of the Royal Astronomical Society of London at the age of 19 and has been a visiting research astronomer at the Australian National University, the European Southern Observatory in Germany, the Californian Institute of Technology, and Harvard University. I hope you enjoy Dr. Block's presentation. He is coming to us from South Africa. You will hear him, but you won't see him. Enjoy the presentation.
It's a great joy this evening to join you online from South Africa. My talk is entitled Esprit de Geometry, or Esprit de Finesse, Insights on the Mind of God from the JWST images. I'm going to plow right in to my talk, and I'll be spending about 10 minutes introducing you to the genius of Blaise Pascal, which sets the tone for the entire presentation. We just have a technical issue to move this on. Blaise Pascal was born on June 19, 1623 in Avignon in France, and he died on August 19, 1662, aged only 39. Now, one of the greatest living experts on the life and the thoughts of Blaise Pascal was undoubtedly Professor Jean Menard, one of the world's greatest experts on Pascal from the Sorbonne. And here I have photographed him at the Rodin Museum, where he's looking eagerly so and intensely so at Rodin's The Thinker. Pascal was a child prodigy. His earliest math work was on projective geometry. It's incredible that he rediscovered all of Euclid's conclusions presuppositions with regard to geometry, Euclid's treatise on the subject of conic sections at the age of 16. He later corresponded with Fermat on probability theory, strongly influencing the development of modern economics and social science. Not a bad treatise, I would say, to write an essay on the conic sections at the age of 16, but there you have it. And to rediscover all of Euclid's presuppositions and suppositions at that incredible young age of 16 shows you the mind set of the genius we are dealing with at this JWST workshop this morning. Also, perhaps what's not commonly known is that Pascal is really the father, in a very real sense, of the modern computer. Before you, you see an image of the Pascaline. What exactly is this image with wheels, the Pascaline? Well, Pascal, not yet 19, constructed a mechanical calculator which could add and subtract, called the Pascaline. These machines were pioneering forerunners to a further 400 years down the line into the development of the modern computer and later on into the field of computer engineering. Here we have a young lad aged 19 who is foreseeing the birth of the modern computer, as you see in this image over here, the Pascaline. Now, what do contemporary colleagues say of Pascal? I quote, "In science and philosophy, Pascal showed an intellectual power which places him on level with Descartes and Galileo, yet he stands alone, grand but solitary in the great intellectual movement of humanity," quote unquote. Pascal's most influential theological work, referred to as the Pensées, or Thoughts, is widely considered to be a masterpiece and a landmark in French prose. Now, forgive my French pronunciation because I do not speak French like my sister-in-law online, Sue Levitt, tonight speaks French so beautifully, but I'm going to try my best in a kind of French English lingo. When commencing on one particular section, Sainte-Beuve praised the Pensées as the finest pages in the French language, while Will-Durant hailed the Pensées as the most eloquent book in French prose. This is how highly esteemed the Pensées are, given the fact that not many people today know about them. The anthropological argument of Pascal makes the case for Christianity by pointing out that any viable worldview must successfully explain the seemingly paradoxical nature of the human condition. What is the paradox? The paradox is this, that human beings exhibit qualities of both greatness and wretchedness. Pascal argues that Christianity offers the best explanation for this condition, greatness and wretchedness, based on its teachings that human beings are created in the image of God, yet original sin has tainted their nature. The basis for Pascal's rejection of the computer model of the mind can be found in a distinction he makes in the Pensées between the spirit of geometry, esprit de geometry, and the esprit de finesse, the spirit of finesse. And I need to come to grips in the next 5 minutes by exactly what does Pascal mean, differentiating between the spirit of geometry and the spirit of finesse, because this lies at the heart of the interpretations, and my interpretation anyway, of the JWST images. Sidney Harris once said that the real danger is not that computers will begin to think like men, but that men will begin to think like computers. And Pascal disagrees very, very strongly with such a statement. According to Blaise Pascal, while the geometric mind is rigorous and exact, it is rigid and inflexible. But this is the important part regarding esprit de finesse, the intuitive mind, the intuitive mind. Pascal says, and I quote, "We feel them, the principles of esprit de finesse, rather than see them." Very interesting. We feel them. How do I feel when I look upon JWST images? We feel them rather than see them. We have infinite difficulty in conveying this feeling to those who do not feel it for themselves. Now, to give you an example of Pascal, the genius of Pascal, who rediscovers Euclid's Elements age 16, we see a picture here of Margot Fontaine and Nureyev, Rudolf Nureyev, and I think that this is where Pascal is heading. But Pascal heads further than this. He only doesn't speak of finesse, but he speaks of the spirit of finesse, esprit de finesse. Again, you see here in a beautiful image, yet again historical, Margot Fontaine and Rudolf Nureyev again. Finesse comes to the fore. Now, God has revealed to me in a very special way that the Spirit, the Holy Spirit, the fruits of the Holy Spirit really fall into the box or the realm or the hemisphere of our minds in terms of esprit de finesse. You know, whenever Jesus speaks, he hits the nail on the head every time. His words are laser-like. They are poised. They echo with the greatest degree of accuracy. Please remember that. Laser-like, poised, echo with the greatest degree of accuracy. Just think of the pointe shoes and the demi-pointe shoes in ballet to further enlighten what I am saying. And so when I look upon the human body, or when I look upon the human brain, when I see what the human brain produces, I see the master potter at work. That's what Pascal did when he wrote his Pensées. He saw the master potter at work. And that's what I see when I look upon the JWST images, is the master potter at work. Now, let's home in, therefore, on the word finesse. Synonyms include refinement. Refinement. The universe is not an accident. It's highly refined. Grace, elegance. What could be more elegant than images from the James Webb Space Telescope? Sophistication, and I've got many more. Adroitness, skillfulness, adeptness, artistry. Everything highlighted in yellow, I see very much so. Adroitness, adeptness, artistry, in my interpretation of the incredible images from the James Webb Space Telescope. You know, my first interest as an undergrad in 1974, I was then 20, was in applied maths and cosmology, and I wrote a treatise, which you can see here. It was written in the year 1973, so I was 19, and it was published by the Royal Astronomical Society of London in 1974 when I was 20. But already when I came to grips with the magnificence of cosmology and Riemannian manifolds and Lie algebras and much besides, my mind was gripped by the beauty of it all, by the finesse of it all, by the artistry of it all, by the adroitness of it all falling into the realm of esprit de finesse. Now, when I grew up as a student in astrophysics and in astronomy, the raving model was one of monolithic collapse, which means that all galaxies collapse from one large primordial cloud of gas, and that galaxies are therefore closed dynamical systems. This was the model in vogue at the time. It was developed by three giants in the area, two of whom I met. Alan Sandage, I met at Caltech. Lyndon Bell, I met in Namibia. And Olin Egan. So they proposed that all galaxies form in a top-down approach, meaning that you've got a big cloud of gas, collapses, collapses, and collapses. But was this true? And I think that James Webb Space Telescope's observations challenge this, but I shall elucidate that presently. Now, for example, if you look at a galaxy, an elliptical galaxy such as Centaurus A, I was taught that this was a closed dynamical system. But no, I see the master of finesse. I see the masterful artist at play, the artist of finesse. And I remember many years ago now, there was a paper by Marc Sauvage and myself in the year 2000, so that's quite a few years ago, showing that there was a spiral galaxy inside this elliptical galaxy, and that in fact it was a merger of two galaxies, which is going to completely challenge the top-down scenario. And this is going to give us most valuable insights into the way galaxies actually form. And it led to an international conference in South Africa, edited by the late Mayo Greenberg and myself. He was the world's greatest living expert on cold cosmic dust, warm and cold cosmic dust. And about 100 astronomers from around the globe flew in for this conference. I think John Mather was there, who later won the Nobel Prize. Now, here's a first deep sky image of a color image of Messier 31, our sister galaxy in the local group, one of our sister galaxies here. And it shows you Messier 31, the triangulum galaxy. But the question really is this a closed dynamical system, as I was taught as a student, as Alan Sandage and Lyndon Bell and Egan suggested, or do we start seeing in these images within the local group evidence for the fact that it's a bottom-up scenario of galaxy formation, that the collisions of galaxies on the grandest of scales. And I remember working with Giovanni Fazio on this. He, of course, was principal investigator for the Spitzer Space Telescope. Shows you the wavelength regimes to which IRAC was sensitive. Then you've got the James Webb, which is the focus of today's workshop. And then you've got the Hubble telescope imaging in the optical and the ultraviolet. So just for the moment, I'll be concentrating primarily on James Webb. Just for the moment, let's look at some images from the Spitzer Space Telescope. And here in Nature, a team of which I was principal investigator found that there was an almost head-on collision. So there, right in our neighborhood, something which James Webb is seeing over and over and over and over again in the deeper universe, we see right on our doorstep that galaxies are colliding. But never could I, as a student, imagine that we would see this so close to home in the Andromeda Galaxy. So here is my dearest friend and collaborator, Professor Giovanni Fazio at Harvard. There is an optical image of Messier 31. But you can see that if we look at it through the eyes of the space telescopes, you see these glowing rings of fire in the infrared. And the only way you can produce those glowing rings of fire is to have Messier 32, one of the companion galaxies, slamming almost head-on into Messier 31. So this was to overturn the whole model of monolithic galaxy collapse. We've seen collisions on the grandest scales right in our local neighborhood within our local group. And I was very proud about this because here I sit at the southern tip of Africa, and yet here is NASA JPL press release. And if you look at the caption, you'll see that an RTB scholar is in the caption because it mentions NASA, JPL Caltech, and myself as director of the Anglo-American Cosmic Dust Laboratory. And so right on our doorstep, we see finesse, not only in the collisions of galaxies, but we see finesse and the laws of nature. And of course, Hugh Ross has written the most marvelous sets of books, I mean, beginning with A Fingerprint of God and many others, on how finely tuned the initial laws of the universe are, the Cauchy data of our universe are, to give rise to our universe, but not only to give rise to our universe, to give rise to the person you 14 billion years down the line. But again, you know, in talking about the laws of nature, and I deal with them all the time, the strong nuclear force, the weak nuclear force, and so on. You see refinement therein, you see grace therein, you see elegance. What would Pascal say about all of this? He'd say those laws are imbued, imbibed, enveloped by the l'esprit de finesse, this incredible artist. Just like if you're a clay pot on the Greek islands, this incredible potter at work, finely tuning the laws with such mastery and such genius. Now to JWST images. The Cartwheel Galaxy is a galaxy around 500 million light years away in the constellation of Sculpture. It's got an outer ring which is expanding at nearly 300 kilometers a second, discovered by Fritz Zwicky, whom I greatly admired in 1941. But how does God envisage the building of the disk of a galaxy? Top down or bottom up? Oh, now that I know about the esprit de finesse, I see the master potter at work, and I see him at work in giving rise to these incredibly beautiful, glorious, masterful, artistic, potter-like images. Well, not potter in terms of ceramics, but in terms of gas and dust spewing out at velocities in the outer echelons of around 300 kilometers each second. And so we understand that galaxies, another galaxy in our local group. I mean, that's why I try to merge what James WST is showing on a grand scale with what's happening on our doorstep. Here's the Triangulum Galaxy. It too is showing elements that it is a bottom-up scenario, and it's not built up as Lyndon Bell and Sandage and Egan suggested. There was a paper of ours put out several years ago, co-authored by my great collaborator and friend Ken Freeman and several other collaborators, including my PhD student, Robert Gruss, who won a gold medal in this area. Very luminous carbon stars in the outer disk of Messier 33. And we just started examining the outer echelons of M33, and we started using the Keck telescope, and we started discovering carbon stars. Those are we are made of carbon-based stardust. Intermediate age carbon-based stars, 0.6 to 2 gig a year, formed as a result of accretion. You see, it goes to show the master potter at work all the time. He doesn't just set the universe in motion and that is it. Galaxies are continually growing from the inside outward, even though you see not only the Andromeda Galaxy, but NGC 598 or Messier 33. And there was a paper in 2007 that the Keck spectra confirmed that the stars at the outer H1 warp were the result of carbon stars being born. The spectra were incredible. I mean, this was just such fun using the Keck telescope to confirm that those stars right on the outer echelons of the Triangulum Galaxy show forth the C2 and CN, the Swan bands, the CN bands. It's again a beautiful, immediate proof that God is a God of finesse, of structure, of keeping his hands moment by moment on the building of the clay potter, if you like, the ceramic clay, but yeah, in astrophysical terms, the master potter at work. Well, there's Herbig-Haro objects. Of course, these are star-forming regions. They're generally very young, lasting no more than a few thousand years. And this is a typical optical image, which I'm just so well acquainted with. And that is, my whole area over 3 or 4 decades is cosmic dust. That's my specialty. And we've used the world's largest telescopes on Earth and in space to probe, to penetrate this cosmic dust. So here it appears as if there's a hole in the universe in this very area and that there's nothing really there. But as we well know, if you can penetrate that like the James Webb Space Telescope does, suddenly you can penetrate this cloud of dust and gas and you can start seeing embryonic baby stars being born. And I'll never forget a magic conference I was at in Cardiff in Wales, and Mayo Greenberg slipped a little piece of paper to me afterwards, and he said, "Dear David, I've been waiting 23 years to see, quote unquote, coal dust. You did it. Thanks, Mayo." And this was just the beginning of a career of about 40 years into working with NICMOS cadmium, beryllium arrays, and so forth to probe this dust. Einstein said that we only really see the tail of the animal, but he says that if we penetrate more, we'll start seeing more of the animal, but we just don't know what lurks exactly so behind this cold cosmic dust. And so here is this Herbig-Haro object in the optical. And now, if you hold your breath a second, I'm trying to move it on. There we go. Through the Herbig-Haro objects 46, 47, I actually met and discussed, had quite a few very interesting discussions with the late George Herbig at the University of Hawaii. But this is a James Webb Space Telescope of that. And you can see, it's amazing to see that behind that cloud of great optical opacity due to the dust grains is this incredibly intricate structure. Again, l'esprit de finesse on the grandest of scales. I find these images from the James Webb Space Telescope, as I know Roger Windhorst will be discussing and Hugh Ross will be discussing and other invitees, just invokes in me that spirit of finesse, esprit de finesse. And remember what Pascal said. He said, you feel it. You can't reason it, but you just feel that you know, 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 that the creator spirit, he creates it so lovingly as the masterful artist, l'esprit de finesse, poised as Margot Fontaine was on her toes. Then, of course, there's the pillars of creation. And I'm just going to allow me to have a little sip of my little cool drink here. But the pillars of creation are elephant trunks of interstellar gas and dust in the Eagle Nebula in Serpens, some 6.5 to 7,000 light years away from the Earth. And I just I've always loved looking at these images of the James Webb Space Telescope, where you can actually see the ultraviolet radiation of young baby blue stars eroding their GMCs, their giant molecular clouds, out of which they have been born. You are seeing stellar maternity wards here, writhing, seething clouds of cosmic dust being impinged by high energy photons from neighboring young blue stars in the environs of these giant molecular clouds. So what are these pillars composed of? These pillars are composed of cool molecular hydrogen and dust, very important, and dust that are being eroded, I've told you this, by photoevaporation from the ultraviolet light of the UV light of relatively close and hot stars. The leftmost pillar is about 4 light years in length, which really does give you an incredible degree of scale. What's interesting, beloved, is that the finger-like protrusions at the top of the clouds are larger than the solar system and are made visible by the shadows of eggs, which are evaporating gaseous globules shielded behind the UV fluxes. And we're really looking at stellar maternity wards, as I say. But again, to come back to it all, what do I, as an astronomer trained in this field since 1976, what do I see? I see a spirit of the master artist at work, the adroitness, the skillfulness, the genius of the artist at work. And I always tell my students, pinch yourself, feel yourself. You are made of the stuff cooked in the interiors of stars. You are made of variable carbon-based star dust. So here we have pillars of creation again. But one of our favorite artists is Van Gogh. And here we see a church, a very famous church, an oil painting of his, created by Van Gogh in June 1890. And so I just decided to have a little bit of fun in Photoshop, I think, and just superimpose, because what's the focus in the church should be, anyway, the Logos. In the beginning was the Word, and the Word was made flesh and tabernacled amongst us. And then, of course, juxtaposed there, I've put in the pillars of creation. So this is a marriage, if you like, which I've put together for this Reasons to Believe workshop on JWST, which you so kindly invited me to online, albeit as I could not travel there again, having just been at incredible RTB headquarters in Covina. But it's a kind of a marriage I've put together of the microcosm and the macrocosm. And I think Pascal might have loved this juxtaposition too. Let's move on to another image. The Carina Nebula, a large, complex area, bright and dark luminosity in the constellation, the southern constellation of Carina. In fact, forming part of the Carina Sagittarius arm of the Milky Way. And you see huge clouds of cosmic dust. Just to give you an idea, before I show you the image, if I may, the star-forming regions are approximately 9,000 light years. That's around 2,800, 2,900 parsecs from the Earth. And it is staggering. I'll never forget Giovanni Fazio himself personally sending me this image the moment it was released. And it is absolutely breathtaking. It is l'esprit de finesse on the grandest of scales. It is the stuff that God has used to create you and me. It is the stuff, it is the material he has made to make Margot Fontaine and each one of you hearing me online from Johannesburg, South Africa this evening. It is an element, it is an image filled with intrigue, filled with passion, filled with mystery, filled with awe, filled with wonder. And again, another image showing you a scale size with a 2 light year bar at the bottom. And you know, what comes up in my spirit is this: what is man that thou art mindful of him, asked the psalmist, and the Son of Man that thou visitest. Well, who am I, Lord, in relation to this? But you see, that's God's Spirit in me saying, David, who are you? And then Jesus himself answers me and says, David, even the hairs on your head are numbered. You see, that's the Jesus I know. It's the marriage of the macrocosm and the microcosm. It's the marriage of the master potter at work. It's the marriage of the sculptor who sculptures and makes each one of you hearing me online with the very material, the raw materials, if you like, as Hugh so well knows. It's the raw materials of which we are made. And the resolution in these James Webb Space Telescopes images is absolutely stunning. Now, of course, again, going to Van Gogh, his Starry Night over the Rhone. I just love this image. I wish I could go to Paris yet again and just see some of these images yet again, these paintings. But again, this is for Reasons to Believe workshop. You might like it, you might not like it, but I've juxtaposed the the cosmic cliffs in Carina with his masterful Starry Night on the Rhone. And actually the oranges merge very well between the reflections of the stars as painted by Van Gogh and the stars in the night sky as captured by the James Webb Space Telescope. And I just love this image because it's saying, David, there's a future for you. David, there's a hope for you. Fuzz, there's a future for you. Fuzz, there's a hope for you. Because him who has designed this Fuzz has numbered the stars. In Psalm 147, he calleth the stars by name. And yet in the next verse, he healeth the broken in heart. And that's where I really work as director of Reasons to Believe Africa, is to marry the macrocosm and the microcosm, to bring the universe down so that people can understand the wonder of being lifted up to the majestic realms of the Logos being made flesh and tabernacling amongst us. Here's another image of L1527 being born, a protostar, very, very young star, earliest phases of stellar evolution. The process will last only about 500,000 years, which is extremely short compared to the age of the sun, which is currently at 4.5 billion years. And these stars, without going into too much detail, hydrogen starts fusing into helium in their cores. And I just love the definition of all of these images with the James Webb. But again, I see these younger star-forming images, they're solar systems in a sense, only around 300,000 years old in the constellation of Taurus. I start seeing them manifesting not just art, but science, and not just science, but also art, but not also art, but finesse, but also not just finesse, but esprit de finesse. Just like you have the spirit of Paris, you don't just have Paris, you have the spirit of Paris, you have esprit de finesse in all these images. And I thank God that I've lived long enough on terra firma to actually see these images from the James Webb Space Telescope. But then there's the formation of solar systems, you know. I think of a system known as AU Microscopia, AU Mike, lies in the southern constellation, which I know well, of Microscopium. It's a variable star, and it has a circumstellar disk of dust. Let me show you right away. Just imagine that you are looking here at an embryonic solar system in the making. What's happened is we've blotted out the light of the central sun or star because it's too bright. But if you blot out the light, then you can see this plane of dust and gas on either side of the star. And so perhaps this is what the solar system might have looked like 4.5 billion years down the line. But I think it's an incredible tribute to the James Webb Space Telescope team, including Roger Windhorst, who's with you today, one of the great minds in JWST interpretations of data, that we can actually look back to the proto development of our solar systems in the veritable stages of being made. I think that is an extraordinary capture. It's almost Genesis chapter 1 all over again, but then applicable to AU Microscopiae. And again, just the resolution and the fine detail. If you examine this pixel by pixel, you see again a God, you discover a God who operates the spirit of finesse, the esprit de finesse, just over and over again. But in the next 5 or 7 minutes, which have been allocated to me, we have light from a distant galaxy here, and then we have a foreground cluster of galaxies, and of course, its gravitational force field bends the light from the distant galaxy to Earth, and we start seeing multiple images of the same background galaxy. We start seeing multiple images of the same background galaxy. That's what you can see here. The orange arcs everywhere. And if you were to take a spectrum of any one of those orange arcs, they'd be identical, and they would match the spectrum of the galaxy whose light is being lensed. What a confirmation of esprit de finesse, God warping space and time by means of gravitational force fields. We're really touching here on the very mind of God, as in the title of my presentation. And so here you can see, if we start looking at spectra of the different galaxies, we can probe our universe right back to the beginnings almost, as Hugh will be addressing today later too, from 11 billion years right throughout to 13.1 billion years. And we can start seeing star-forming regions at a redshift of greater than 10. But the important thing here is that it's again bottom up, just as we found in the local universe. That's what I find so encouraging between the work which I was PI of in the local universe, Messier 31 and Messier 33 and so on, and these incredibly distant galaxies formed in a rather mature phase, 13 billion years and more down the line, but it still discards the model of sandage. It's still the spirit of finesse. It's the building of the galactic disks from the bottom up, not from the top down. He has a little red blob. You might say to me, David, what exactly is that red blob? Well, that little blurry red blob might not look like much, but it's the current record holder for the most distant object known in the universe. There might be one slightly more distant. Roger will fill us in on that. But this galaxy lies at a redshift of 13.2, which means that it looks like as it did only 320 million years post-Big Bang. I could never have believed that we would observe galaxies only about 300 million years post-Big Bang. And I have to also pay great tribute to a friend, Garth Illingworth, who has been instrumental in so much of this data interpretation of dynamically open systems. And now, in the last few minutes allotted to me, this is how I see the universe. The universe started off in a gargantuan Big Bang some 14 billion years ago. Then there was an afterglow for around 375,000 years. I actually wrote a book on that alone, Our Universe, Accidental Design, which was prefaced by 2 Nobel Prize winners. That book's available on our RTB Africa webpage. Then there was the Dark Ages, and then there was the development of galaxies and planets and stars and so on. But again, if I look at that development or the evolution of the universe over time, I see the greatest degree of finesse in the kosher conditions, and you and I and the scholar community were discussing just a little while ago. What do I see in the kosher data of the universe? I see refinement in yellow. I see grace. I see elegance. I see wisdom. I see mastery. I see genius. I see the Spirit of the living God at work. I see the Spirit of the living God coming down and tabernacling amongst us. I see the Spirit of the living God impregnating the minds of scientists like Stephen Hawking, who even said the remarkable value of these numbers is that they are finely tuned to make possible the development of life. I see the Creator coming down. I see him wanting to lock into the heart. That's what Pascal was so good at. He locked into the heart, and he said, in matters of the heart, and he said, the heart has its reasons, which reason does not know. The heart has its reasons, which reason does not know. May God bless you with his Holy Spirit and his spirit of finesse as you further explore the images, the remarkable images, and interpretations thereof of the James Webb Space Telescope. I thank you.